Hey everybody, welcome to the Module 2 Topic 1 review for Algebra 2. This is the topic that focuses on factoring, finding zeros, polynomial division, and things like that. So we go more in depth on how to find really just zeros or factors of polynomials. So let's get into it. This first problem is just a factoring problem. Factor and sketch a graph. They give us some factoring methods that we could potentially use: greatest common factor, factor by grouping, and difference of squares. And so let's just try to tackle this thing. The first thing I notice is that it's not a quadratic, right? So it has x to the fourth. That means I can't do my normal, a times c, b, figure out the two numbers that multiply to this, add to this. Maybe we'll have to do that in a second, but we have to split this up. First of all, we have to somehow break this down into some factors. Maybe they're degree 1, or maybe they're quadratics, and then we can factor using our normal method from there. Anytime I see a to the fourth polynomial, I have to be thinking one of two things: either factor by grouping or greatest common factor. And in this case, if I take a look, I notice that each of these terms, 2x to the fourth, 2x cubed, 18x squared, 18x, they all have an x in them. And so right away I can factor out an x, right? And then let's actually do a little bit more thinking. Is there also something else I can pull out with an x? And there's a 2. So I can actually take out 2x from this entire polynomial, meaning I can rewrite this inside thing in parentheses as all of these terms basically divided by 2x. Like, what do I have to multiply here that gets me back to where I originally was? Like, if I were to redistribute it. And so what that would mean is if I take 2x and I multiply it by x cubed, I'm going to get back to 2x to the fourth. And then that same process, plus x squared, right? 2x times this will get me back to 2x cubed. And then this one divided by 2x is minus 9x. And then finally minus 9, okay? So we've done one step. We've taken out a factor of 2x, and that's good. But I'm looking at this now, and it's still a cubic, which means I need to still do some extra work. And I think this is where I'm going to do factor by grouping. All right, so I pulled out a greatest common factor. Now I'm going to do factor by grouping because I have a cubic. And so here's what that means. I'm going to look at two groups, right? I have this first two set of terms and then the second two set of terms. And I'm going to look for things that are in common between my first group. So I'm going to look for things that are in common between x cubed and x squared. Well, there's an x squared in both of those, right? X squared can go into x cubed and x squared can go into x squared. Well, what would be left over if I factor that out? Well, it would be x cubed divided by x squared, which is just x, and then x squared divided by x squared, which is just 1, okay? So in total, and I'm going to do big parentheses here, and I'm going to not forget about this 2x, but we did factor out this 2x at the beginning. You could forget about it for a second, bring it back in at the end, but I'm just going to keep writing it big like this, okay? So we have that. And then in the second group, negative 9x minus 9, well, I noticed that both of those have 9s, and both of them are negative. And if I have the chance to pull out a negative, I'm going to do that. And so I'm going to pull out negative 9, and that leaves me with negative 9 divided by negative 9 is, or negative 9x divided by negative 9 is just x. And then same thing, negative 9 divided by negative 9 is positive 1. Okay, so this is interesting. We know that we've kind of done something right if we notice that I have two things in parentheses that are the same, like this and this. Because what that means is I now have, and I'm just going to rewrite the beginning of my polynomial again. So this 2x is still hanging around, but I'm going to do big parentheses here. I now have a x squared and a negative 9 that are both multiplying x plus 1, right? X squared is multiplying x plus 1. Negative 9 is multiplying x plus 1. That means x squared and negative 9 are multiplying x plus 1, like that. Check that out. So we have our x plus 1 here, our x squared minus 9 there. These two things that I highlighted in pink are multiplying the yellow. And you might be like, well, where'd the second one go? Where'd the second x plus 1 go? Well, if I were to multiply this out, if I were to distribute this, I'd have to multiply x squared times this set of parentheses and negative 9 times this set of parentheses. And so the x plus 1 is just here. I just combined these two terms together into one polynomial. Okay, so let me clean this up and let me show you what we're actually working with here. So in total, here's what we have. I'm going to get rid of the highlighting. I'm just going to rewrite it real quick. So we have this 2x that we factored at the beginning. That's multiplying x squared minus 9, and that's also multiplying x plus 1. Okay. So right now, we've officially factored it down to a degree 1, a degree 2, and a degree 1. And sometimes we might be done with the process right here, but if I notice, and they give us a little hint with difference of squares, this method right here in the middle, or this polynomial in the middle, x squared minus 9, is in fact a difference of squares, because x squared is something squared, it's x squared, and 9 is something squared, it's 3 squared, and they're being subtracted, meaning they're taking the difference, okay? And so you just have to remember this rule with difference of squares. This thing can simplify into this. Becomes f of x equals, we still have this 2x, but this thing now becomes x minus 3 and x plus 3, right? These, if I multiplied them out, I'd eventually get an x squared from the x times x. I'd get a minus 9 from the negative 3 times 3. But then the b term, like the something x, would cancel out because I have negative 3x and then positive 3x, and those two together combine to 0, right? Positive 3x minus 3x is 0. And then we have this last polynomial, x plus 1. And that's it. Cool, we did it, we factored it. But now they're asking us to sketch a graph. And we can do that pretty easily because we now know, and this is kind of like our last unit, we know a lot about this polynomial and what it looks like now, because we know that each of these represents an x-intercept or a 0 on the graph, okay? And those come from the values of x that we can plug in that make the output 0, right? That's what we're trying to find. That's just an x-intercept by definition. And so if I take these, break these down step by step, I can just set these equal to 0 like this. And I'm doing this the long way just to explain it the first time, right? But really all I'm doing is solving these little equations, these little one-step algebra equations to figure out what value of x can I plug in to make the set of parentheses 0, because everything's being multiplied, right? And so the output would be 0 in total. Well, that's just going to generally be the opposite of what's in the parentheses. But in this weird case of 2x, we can't forget about that, especially if we pull out anything that's just an x. We have these sort of monomial instead of binomial terms. The value of x that makes this 0 is 0, right? Because I could divide 2 to both sides and I just get x equals 0. And so I know I have a x-intercept right in the middle, right at 0. This one would be at positive 3, because you can just add 3 to both sides to find that out. So I have one at positive 3. I'm just going to say that's right there. I'm making it up. I have one at negative 3, because I have to subtract 3 to see that. So I have one same place but on the other side of the axis. And then one at x equals negative 1, because I can subtract 1 to both sides. So that means I have one, let's say, right there. Okay, so I know those are my x-intercepts. And so the last thing I have to check is which way can I draw my end behavior? Like, does the graph look like this? Does it look like that? Who knows? Well, based on the leading coefficient, which is the number in front of the leading term, it is positive. And so we know from the last unit that that means it is concave up like a cup, or both ends go towards positive infinity. And so it looks something like this, like a W, all right? Which we just caught a W by doing this problem. Okay, next one. So this one we have to factor it again. But they say greatest common factor in box method. Box method, I think this is Mrs. Mueller's way of saying the normal way, right? We can do this with the area model. So let's do it. Let's plot a greatest common factor. So let's find what's in common between each of these things. Right away, I notice there's an x, because there's an x here, an x here, and an x here. So let's plot x. So I have f of x equals x. And let's check if there's any number that could go into all these things. Well, I notice they're all even, so 2 can go into it. But is that the greatest common factor? No, because 4 can go into each of these as well. So let's factor out a 4x, okay? And then in parentheses, it's going to multiply whatever's left over, which is 4x times, in this case, x squared. This times this would get me back to this, or 4x cubed divided by 4x is 4x, or is x squared. This one is going to be minus 2x. And then this last one is going to be minus 3, right? And the way I'm kind of checking this, if it feels like I'm going fast, I'm kind of just doing like the distributing in my head. I'm like, what number do I have to multiply this by to get back to this? Which is just kind of dividing as well. Okay, so now we have a kind of a similar situation where we have something pulled out in front, this 4x. That's going to give me a 0 at x equals 0, right, or an x-intercept. But now we have to factor this quadratic. And this quadratic is actually not too bad to do. And then we don't have to do any sort of like grouping or anything because it's just an x squared thing. And so this is where I go into the way that I like to do it. I don't know, not everybody's in my class that's watching this video probably, so bear with me. You can just, skip this part of the video if your teacher does it another way, but I like to do it the, I guess, delta math way. I don't know. Which is just to organize my thoughts like this. So basically what I'm saying is I need to find a times c. That's the first term and the last term. That's negative 3x squared, okay? And then b, which is the middle term, goes here, negative 2x. And so I need to find two numbers here and here that multiply to this and at the same time add to this, okay? So I start with the multiply. Like, how do I multiply to negative 3? Well, I know it's got to be 1 times 3. That's the only way to multiply to 3. And then because it's negative, one of those has to be negative. And so then I'm like, okay, how can I make my result when I add them also negative? And that's if the bigger number, negative 3, is the thing that's negative, right? So if I add these two together, I get negative 2x, okay? And let me be a little more specific. Let me write x's here. So then the box method part is, what do you do with this? Now, this is a degree, or sorry, the leading coefficient is 1, and so we can take our little shortcut if we want, but I'm just going to go to the area model and just do my due diligence here. And so then when we're in the area model, the box method, as it were, we have to put in the elements from the thing we're factoring, our original polynomial, into these 4 squares. Okay, so the x squared goes in the top left box. The constant, which is just the number, goes in the bottom right box, negative 3. And then this negative 2x, well, we're like, which box should we put it in? The answer is both, because we just found how to split it up. And so this is where we input our two sort of puzzle pieces that we figured out by doing this method. And now we're just figuring out the edges of the area model, and that's going to be the factors of this thing. And so I start from the top. What's the way to get to x squared? By multiplying. Well, it's got to be x times x. How do I get negative 3x by multiplying? Well, I'd multiply x by negative 3. And then how do I get x into 1x? Well, I multiply by 1. And then double check, 1 times negative 3 is negative 3. And so the area model works, which means that this whole thing factors into x minus 3 times x plus 1. And we still had this factor of 4x out in the front. And so we can write it like this, okay? And then sketching the graph is going to be the same process. I'm figuring out which values of x give me some x-intercepts, make the output 0. Once again, it's going to be x equals 0 here. That's the only thing I could multiply by 4 to become 0. This one's going to be x equals 3, and this one's going to be x equals negative 1, right? Same process as what I did in the last problem. And so let me plot those here at 0, 0, at positive 3, and at negative 1. And then we should double check our end behavior. This is a cubic, and so we know it's going to have the odd degree end behavior, which either looks like this or like this. And because it's positive, that means that as I increase x, right, the leading coefficient's positive, that means I'm going to end going to positive infinity, or it's going to look like the positive slope of a linear curve, right, or a linear function. And so I know that this is the way that the graph goes, as opposed to this, right? That one's wrong because it matches the end behavior. Like this tail is pointing up, which means we're going towards positive infinity because the leading coefficient is positive. Okay, cool. Next up, factor the polynomial. And this one, oh, I drew a little red dot right here. Oh gosh, that's gonna bother me. Hold on, I can do something to fix it. Just give me 1 second. You gotta bear with me. That's my bad. That's my bad. So we're gonna make a little box. We're gonna go like this, and we're gonna cover it up like that. Check that out. Isn't that sick? Okay. Factor the polynomial below. So this one, you might be like, wait, hold on. They didn't give me any methods, and that's true because this one's kind of just like a moderately difficult factoring problem that you use the normal way to solve, right? Oh no, I was gonna move. Oh no, I wanted to just move it up to the screen. Oh, there's my box. Okay, there we go. And so here's what I'm gonna do. I'm just gonna set it up the same way. We're gonna do A times C, and we're gonna do B. Once again, maybe your teacher does a little bit of this nonsense, and good on them. But I was taught it one way, and I'm gonna teach it that way for the rest of my life, and I'm never gonna change, and you're never gonna change me. Okay? I'm joking. 9 times 4, that's A times C. 9 times 4 is 36. X squared. Okay, interesting. And then B is the middle term, that's 12x. So once again, I need two numbers that multiply to this, and at the same very time, they gotta add to this. Okay, now 36 is a cool one. We could do 9 times 4, like we just did. We could do 12 times 3. We could do 36 times 1. We could even do, no, that's it. Except for the correct answer, which I skipped, which is probably the one I thought of first, which is 6 times 6, right? 6 times 6, 6 times 6 is 36. It's true because it rhymes and no other reason. And if I add 6 plus 6, check that out, I get 12. Which means that my two little puzzle pieces here have got to be 6x and 6x. Since everything's positive, we don't have to worry about negative signs or anything. Okay, so now we go to the area model. And now I'm going to plug in, once again, my original polynomial. Forget about the 36x squared. Forget about all this. We're going back to the OG. Another day, another victory. And we're going to plug in these terms. The 9x squared goes in the top left box. The 4 goes here. And then the 12x, we figured out, is a split of this and this. And that goes here and here. Okay. Doesn't matter where you put them. And it also doesn't matter in this case because it's the same thing. But now we have to figure out the edges. So I'm figuring out what times what. This thing times this thing has got to be 9x squared. Okay. Here's where it gets tricky because we got to do a little planning. We got to think a little bit because there's a couple ways to multiply to 9, right? 9 is not a prime number. Okay. We can do 3 times 3. All right. Or we could do 9 times 1. Is there any other ways? I don't think so. Okay. And if I did 9 times 1, like 9x and 1x, right? If I look down the line, I'm looking at, is there any way to turn 9x into 6x? Well, not by multiplying by a whole number. And so it can't be 9x and x. It has to be 3x and 3x. Okay. And then you can look at this and be like, okay, 3x times 2 is 6x. And then 3x times 2 is 6x. And then 2 times 2 is 4, which means we're good. We have 3x plus 2 times 3x plus 2. Wait a minute. That's just the same thing. That's just the same thing multiplied by itself. In other words, that's just this. Oh no, we've uncovered a secret, an uncovered secret that just told us we unraveled the treasure map, and it just told us we wasted our time because this thing is a perfect square trinomial. Oh my gosh. Trinomial. Right? Remember that? A squared plus 2ab plus b squared. I mean, look at this. The 9 and the 4, it's a dead giveaway. Those are perfect squares. We have to be thinking about perfect square trinomial in this case, but I didn't. I just had to do all the work, but that's okay because I showed you both, and that's what I was trying to do. It was actually a ruse all along. I knew it was a perfect square trinomial, and I still wasted my time, and that was for you, and you're welcome. Okay. So anyway, perfect square trinomial, if you notice that, if you're like, if this thing is squared, this thing is squared, and then this is 2 times the square root of both, right? Like this is 3, this is 2, and this is 2 times 3 times 2, right? It's 12. Then you could just take the shortcut and you don't have to show us any work. You'd be like, oh, that's a perfect square trinomial. This is the answer, okay? And that should be on your note sheet, at least if you're in my class. But you could also just factor it the normal way, like I did, okay? Let's move on. Number 4. Factor polynomials using difference of squares. Difference of squares. Okay, difference of squares is cool because it's another shortcut, kind of like perfect square trinomial. And it goes like this. If I have a squared plus b squared, I actually talked about this in the first problem. Sorry, a squared minus b squared, because it has to be difference of squares. Then I know that this has got to be a plus b times a minus b. All right? A plus b times a minus b. And so what we have to check is if these things could possibly be squares. Like, could this be something squared? Okay? Now, in bold letters, they had told us, don't forget to check for a greatest common factor first. And if I didn't listen to the bold letters, then I might be kind of stuck because I noticed right away that 5 is not a perfect square. And after a little bit of thinking, I noticed that 405 is also not a perfect square. And so I'm like, okay, I can't use this method. But they told me to use this method. And so there must be a common factor, and it's just 5. So what I can do is factor out a 5. And what I'm left with is x to the 4th minus... quick maths. Hold on. I just got to do the math in my head real quick. 405 divided by 5. Yeah, 81. That's exactly what I was thinking, right? And now if I look, I'm like, okay, hold on. 81 is a perfect square. It's 9 times 9. X to the 4th, though, that's not a square, right? That's not something squared. But then you got to be like, hold on. If it's x to the 4th, that's the same thing as x squared squared. Because remember, if you raise a power to a power, you multiply. Don't worry, if you don't remember that, that's okay. We'll do power rules in a bit, semester 2. And so what this can become is if I set this equal to like my a term and this thing equal to my b term, then I can use this sort of formula and say that this is the same thing as 5 times a would be x squared, sorry, and then b would be 9 because they have to be the square roots of those. A squared would be x squared, or x to the 4th. No, what am I saying? No, wait, what? Hold on, I'm confusing myself. A is x squared because this is what it looks like right now. I want to write it in this form, meaning I need to take the square roots. I'm kind of doing air quotes for square roots. This has got to be x squared plus 9 times x squared minus 9. And that's it. So this was kind of just, do you know the rule? Do you know what different squares means? And if you don't, write it down. Write it on your note sheet. This is important. And then we're like, after difference of squares, check out difference of cubes. You're never going to believe what's next. It might seem crazy what I'm about to say. Then we also say check for a greatest common factor. Okay, so let's talk about sum/difference of cubes. And this one is a little more tricky, and it has the same sort of formula going on here, where you can rewrite a cubic thing, like a thing with x cubed in it, as long as both terms are cubes, perfect cubes, meaning something times something times something, if those things are being added or subtracted. So it doesn't have to be difference. It can be sum or difference, okay? So check this out. Can we possibly find a greatest common factor that results in me getting 2 cubes, okay? And now if it helps, you might want to make a little cube table somewhere on your review sheet or note sheet, whatever you want to use. In my class, you can only use the note sheet. And so I'm going to be like, 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. And then 5 cubed is 5 times 5 times 5, which is 125. And those are probably pretty good for you to memorize, okay? And so what I'm really looking for is there any way I can figure out, do any of these go into this, right? And if I look, I see that 8 is in fact a factor of 24. And so really what I want to end up with is I want to turn this first term into 8x cubed because that is a perfect cube. That would be 2 cubed times x, right? Or 2 times x all cubed. That would result in this. And so what I need to do is factor out the number that leaves me with 8, which would be 3, because 3 times 8 is 24. And then I just have to figure out, hopefully 3 can go into 375. It'd be a mean problem if it couldn't. So let's go 375 divided by 3. It's 125. So this is going to become 3 times 8x cubed minus 125. Well, now we're set up because I know that my a term, right, the first thing that I'm cubing is 2x, right? Because 2x all cubed, which would be 2 cubed times x cubed, which is 8x cubed, right? And so this thing works out. My a term is just the cube root of this. And then 125, the cube root of that is going to be my b term, which is 5, like we showed here. So b is 5. Okay. Oops. I was going to... What am I doing? I don't know what I'm doing. All right. B equals 5. So then I have my a and b, and let's just look at our difference of cubes because these ones are minus. So we're going to use this top one. And we're going to say that this is equal to 2x minus 5 times a squared. That's 2x quantity squared. Got to be careful with that. Plus 5 times 2x. That's a times b, right? Or 2x times 5. Plus 5 squared. Okay. Now, we got to be careful with this a squared thing because it's a entirely squared, meaning it's this 2x being squared together. And so let's rewrite this for our final answer because we're about to be, actually, we're not almost done. We have to factor this thing after. Oh, my goodness gracious. Okay, here we go. So we have 2x minus 5 times, now remember, kind of like I did here, an exponent almost distributes itself. And so I have to square the 2, which becomes 4x and squared. And then this becomes plus 10x, okay, from 5 times 2x. And then this thing becomes 25, okay. And so now we're here. And once we're here, we kind of just look at this, right? And actually, I just said we have to factor it, but I'm realizing now that this thing doesn't factor nicely because it would like be above the x-axis. There's no x-intercepts for it. And so once I see this, I think we're done, right? There's nothing else to factor. This thing, I mean, you could factor it over the imaginary numbers if you so choose, or you could plug into the quadratic formula. But we've officially used the sum/difference of cubes. And so here is our final answer. But the big thing is, don't forget, if you have an a that's being squared together, make sure you square the number in front as well. Okay, so you got to believe me, if you multiplied this back out, you'd end up with this. It seems a little bit crazy, but it's true. All right, let's go on. Divide using long division. Use a separate sheet of paper. No, thank you. Okay, we're going to do this by hand. All right, so let's just get on with it. Let's just do long division. So here we go. First things first, I'm going to rewrite my polynomial that I'm dividing, which is the dividend, and I'm going to write it inside of my little divisor thing or whatever the division symbol, and then I have this x minus 8, which is my divisor, right, the thing that I'm dividing by. Okay, so if you forgot how to do this, here's what we're looking for. It's almost the same process. I mean, it is the same process as long dividing regular numbers, but we're looking for how do we turn x or x things into other higher degrees of x, okay? And so really my guiding light is this value of x right here. This is the thing I'm going to be writing about in the quotient up top, all right? So let's get to it. X times what gets me to x cubed? Well, that's just x squared, right? So x times x squared gets me here. And so now what we do is we take this, and just like in long division, we now multiply it by the thing we're dividing by, okay, which would be x times x squared, x cubed, and x squared minus 8, which is minus 8x squared. And then we subtract. All right, here's where it gets tricky because I'm subtracting this whole thing in parentheses. I'm not just subtracting the x cubed, I'm also subtracting this 8x squared. And so you can think about it in a couple ways. You could either distribute the minus sign, if this helps you, and kind of just write it in. Maybe you could erase this parentheses and change this to a plus. That's one way to think about it. Or you can just keep the parentheses there and remember that we're subtracting the entire thing. That's what I like to do. I don't like distributing because I might get confused later down the road when I'm like trying to actually subtract, but I don't have to. I have to add or something. Yeah, I don't know. So let's just subtract my polynomial. That means x cubed minus x cubed gives me 0. Good. And then negative 2x squared minus negative 8x squared. Well, that's negative 2 minus a negative. That's negative 2 plus 8, which is 6x squared. Okay. So now once I'm here, this is the new thing that I'm trying to turn x into. So once I've done this whole process once, I'm now looking at this. This is now my goal. What do I need to multiply x by? Well, I know I need to multiply it by 6 to get it to be 6x. And then x times x is x squared. So it's going to be x times 6x gets me 6x squared. And then we do it. So we multiply this times x minus 8. And we get 6x squared. And then 6 times 8 is 48. So minus 48x. And we need to subtract them, but I need something to subtract the x from. And so we drop down this 50x, this minus 50x. And so that goes here. Okay. So now we subtract. This thing cancels out, which is what we wanted. Good, right? These go away because it's 6x squared minus 6x squared. And this becomes negative 50x minus negative 48x. Well, that's subtracting a negative, so it's a positive. So this becomes minus 2x right here. And now this is what I need to turn x into. We've now done a full another step of the process. To turn x into negative 2x, you multiply by negative 2. And now we actually do that, right? We multiply this times this. And so we say this is negative 2x and then plus 16. And then we're going to subtract them, but I have to drop down this number. So this is this plus 11 goes right here. We then subtract negative 2x minus negative 2x cancels, it's 0. And then 11 minus 16 is minus 5. And so my remainder is negative 5, which means that my final answer, this division thing, is x squared plus 6x minus 2, right? That's my quotient. That's what I was writing up here, my final answer, minus 5 over x minus 8, because my remainder was 5, or negative 5. And like if you remember from long dividing just regular numbers, your remainder is almost like a decimal that goes along with it. And the way to find that decimal is you take the remainder and you divide it by the divisor, what you were dividing by, and you get this. Okay, for sake of time, I think I'm going to skip this one, but I'll give you a little warning sign, okay? This thing is missing something. And when you do your long division here, you want to make sure that you don't miss anything, meaning you need to have p cubes, you need to have p squares, you need to have p's, and you need to have regular constants, okay? This one is missing one, and in fact, it has some amount of p's in it, right? Regular p's, p to the 1, and it's just 0 p's. And so here's how I would set it up. If you're actually going to go divide it, you have this p minus 1 on the outside, then you do p cubed minus 6p squared plus 0p plus 5, right? Actually, let's just do it. You know, like we can run through it. So let's just do it quickly. So once again, I'm just turning p into things. And so p times p squared gets me to px cubed. And then we actually multiply it and we subtract it. And so let's do this. P's cubed, or p squared times p is p cubed. P squared times negative 1 is minus p squared. Then we subtract. Negative 6 minus negative p. These cancel, by the way. Negative 6 minus negative p is negative 5p squared. And now this is what we're trying to turn into. So we go minus 5p. And then we actually multiply it. And we drop this down. Plus 0p. And then we do minus negative 5p squared plus 5p. And then we do this. And then we're subtracting 5p. So we go here. And then I do minus 5. And then we multiply. We bring this down. We do plus 5. Then we multiply this. Negative 5 times p is p plus 5. And then we subtract this, or 5p plus 5. Negative 5p plus 5, I mean. And then we do this, and this cancels, and then this is 5 minus 5, which is 0, so we have remainder 0, which means that this thing is evenly divided. This is p squared minus 5p minus 5, with no remainder. Thank you. Now, if you didn't do the 0p, it wouldn't have worked out. You can watch it half speed. All right, remainder theorem. So we talked about this. The remainder theorem is this, okay? So you're dividing by something. We're going to call this thing, x minus r. This is the thing you're dividing by, this x plus 1, which would mean in this case that r equals negative 1. It's the root. It's the thing that makes the value 0, right? Well, if I plug into my function, let's call it f of x, right? This is this thing. This is f of x. If I plug in f of r, that's going to be the remainder after I divide it out. Okay? It's going to be the remainder after I divide it out. Well, what does that mean? Like, why does that matter? Who cares? How can I figure out if it's a factor of the given polynomial? Well, we have to do it like we just did in the last problem and think about it as, if I can divide out something like p minus 1, and I end up with the remainder of 0, that means it evenly divides into it, and that means that it's a factor of this polynomial. That means it's one of the ways that I can rewrite this whole thing, okay? Which means if I plug in f of r, right? In this case, if I plug in, I'm just going to write it in this case. In this case, if I plug in f of negative 1 in and get a value of 0 as like my output, like the evaluation term, then I know it's a root or a factor, because it would have no remainder based on the remainder theorem. Okay, so let's do this. Here's what I mean. So we figured out what r was. It's going to be the opposite of whatever's in parentheses, because remember, we write it x minus r. So that means our root, the value of x that makes it 0, is negative 1. And it kind of makes sense, right? Like if this thing has a value of 0 at negative 1, then that means negative 1 is a 0, right? And so let's just plug it in. So I'm going to plug in f of negative 1, if this thing is f of x, which means every time I see an x, I'm going to replace it with negative 1. And so we have negative 1 to the 5th minus negative 1 to the 4th plus 8 times negative 1 cubed plus 7 times negative 1 squared minus 6 times negative 1. Oh no, I ran out of space. Scoop, scoop, squeep, scoop. And then minus 3. And then this is where we just plug it into a calculator. So we have our handy dandy TI-84 here. Yeah. And then we just go negative, let's just type it all in at once. Negative 1 to the 5th minus negative 1 to the 4th. Make sure you use parentheses when needed. Plus 8 times negative 1, all cubed. Plus 7 times negative 1 squared to the 2. And then minus 6 times negative 1. And then minus 3. Oops, I'm messing up. I'm in my exponent. Keep that there. Okay, and then where I'm at 7 times negative 1 squared, minus 6 times negative 1, and then minus 3. Enter. It's 0, which means f of negative 1 equals 0. So x plus 1 is a factor. Woo! And that's it. Okay, so if you plug in the thing you're dividing by, the root, like that's what you would use in synthetic division, you get the remainder if you were to divide it out. So save yourself some time, check if it's a factor, and then you can do it like that. Speaking of synthetic division, let's do one, okay? Which one's harder? Because I only want to do one. No, I'll do both, whatever. That's fine. I'm here all day. Here we go. Okay, so synthetic division. Here's how we set it up. First of all, we have to figure out what the root is. Like, what is the thing that goes here? And that means we need to figure out what value of r, in this case, which is really confusing because we normally call this thing r, but whatever. This thing, we have to figure out what value can I plug in here to make the output 0. Well, that's going to be negative 7. And so that goes here, all right? And sort of this outside of the synthetic thing. Then we need to set up columns. We're going to have one column for each term in our polynomial. Okay, and so our first thing is r to the 4th. Well, what you write here is the coefficient, which is the number out in front. If it's just r to the 4th, then its coefficient is 1. If it's 17, then it's 17. If it's 68, it's 68, and so on. Okay. And now we're set up and ready to go and do this process that we're going to do every time. And the process goes like this. First thing, you drop this number down. That goes here. All right. Then you're going to do this step a bunch of times. You're going to take this R term, okay, the thing we're using that came from this, the opposite of this number generally. If it's like 3R, then you have to solve for R, right? It's the value of R, in this case, that makes the output 0. We're going to do this number times -7 because from this. And that's going to go right here, times -7. So 1 times -7 is -7. And then you add these. Okay, so it's a little bit different from long division because we've been subtracting a bunch, but now we're adding. One of the reasons why is, I mean, we made this thing negative, and so we're doing the opposite, right? And so now I do this. 10 or 17 plus -7 is 10. And now we do times -7. Times -7 again. And then we write that here. That's -70. And then we add. Plus. That's -2. And then we do the same thing. Times -7. That goes here. That's -14. Sorry, +14 because negative times negative. And then we add. Plus. This becomes -5. And then we multiply it times -7. A negative times a negative is a positive. So we get +35. So then we add and we get 0. And once we're done, once we're out of numbers, this thing is going to be our remainder, which is 0 in this case. And so our final answer is weird because we don't have any x's here, right? We just have these weird numbers. But really, this is the same thing as the quotient, the thing that was up top in the long division. It's just missing the variables. And so here's how we know how to start. First, you look at what were you dividing in the first place? Well, I was dividing r to the 4th, and I divided out an r. That means the biggest thing is going to be r cubed, and that's going to be here. So we're going to have 1 r cubed plus, and we use these numbers to tell our coefficients, 10, and we work our way down the line, r squared, minus 2r minus 5. And then you know you're in the right place because you run out of remainder. And so we're done. That's it. Right? If we had a remainder, we could write it as like plus 0 over r plus 7, right? But our remainder is 0, so we don't really have to write that. Okay, let's do the last one. We're on the last problem. Here we are. Okay, I was going to skip it and let you do it for time, but we're here. And this is another tricky one because there's some things that are missing. And the synthetic is the exact same thing. So we can't leave out any terms even if they're not apparent. Okay, so what I mean by that is every term in the synthetic needs a place or needs a row, a column in our sort of setup here. And so our first one's going to be 2 because that's our leading term. But then if I look here, you might be inclined to write 7. However, that's 7x. And there's something that goes between x cubed and x, and that's x squared. And since there's none of them there, that means we have 0 x squareds, which means in our synthetic sort of column setup, we need to write a 0. It's for the x squared. It's just like we need to remember those who are, gone. That's sad. But, we can't, they're still there. They're just not there. Like 0. And then 7 goes there, and then 6 goes there. And now we just do the same process. So the number that goes here is the value of x that makes this 0, which is going to be -1. And so that's my r value, the thing I'm kind of doing the synthetic with. And so we drop this down. We get 2. Okay. Let me do it in green. And then we do 2 times -1. That becomes -2. And then we add. So same thing. So we get -2 here. And then we multiply times -1. And that means we get +2. And then we add. And that means we get 9. And then we multiply times -1. And we get -9. And then we add. And we get -3. And that's our remainder. Okay. And so our final answer is going to be this. Final answer is going to be 2. And then the thing I'm dividing out was x cubed minus x squared. And so I'm going to be left with, divided by x. And so I get x squared here plus, I'm looking at this, minus 2x plus 9 with a remainder of -3, which means we'll write minus 3 over x plus 1. And that's it. All right, we did it. All 10 problems done and dusted. This review is long for sure, but I feel like these problems, once you get the hang of them, are not too bad. Remember, all we're doing really is finding roots, like figuring out when things are x-intercepts or zeros or whatever. And so we're doing a lot of different ways to figure out when the equation is equal to 0, which seems really boring, but, well, it is really boring. So thanks for watching, and good luck on the test. Good luck studying. Remember, if you're in my class, you can only use that note sheet. So if you want to follow along and write this on your note sheet, feel free, but you got to make it. All right. Catch you guys later. Thank you. Bye.